Tahoe. I always like to start though by talking about Mark Twain. He came up here in 1861, and he was actually going to stake a timber claim, but he was so moved by the lake that 10 years later he wrote in his book Roughing It 2 chapters about Lake Tahoe, and he called it The Fairest Picture, the Whole Earth Affords. And he actually camped up here in the North Shore near Tahoe Vista. Fortunately, he started a wildfire. When he let his campfire get out of control. But he wrote very eloquently about it, and it was the lake that he compared all other lakes to. He traveled around the world. Lake Tahoe was his gold standard that he always compared other lakes to, and no other lake ever measured up to Lake Tahoe. Strangely, though, once he left the area, he never came back. So he always held fond memories of his time at Lake Tahoe, and I hope that you share those same kind of memories. Now, this is a quick overview of the cultural and environmental history of Tahoe. Basically, it's how the environment and people have interacted together to make Lake Tahoe what it is today. But we begin with the first inhabitants at Lake Tahoe, which is the Washoe tribe, which have inhabited the area for about 1,300 years. There's been human presence in Tahoe probably longer than that, but organized as the Washoe tribe. This was their summer grounds. They would come up and camp around the outlets, the streams, and fish for the native Lahontan cutthroat, which are no longer in Lake Tahoe. And they camped in family groups. They also held Lake Tahoe to be the spiritual center of the tribe. So not only did Lake Tahoe nourish their bodies, but it also fed their spirits too. And there are certain areas around the lake that hold very strong spiritual value, like for instance Cave Rock. Only certain members of the tribe were allowed to go near Cave Rock. They would make offerings to Cave Rock and would receive the wisdom from the rock that the shamans would then return to the tribe. After summer, they would all then relocate out of the Tahoe Basin, obviously because of the winter snow, down to the lower valleys in Carson Valley and as far north as Honey Lake, where they harvested pine nuts, and that was also a major staple in their diet. They're still in the area, but their tribe was pretty much decimated with once Tahoe became overrun with Euro-Americans in the late 1800s. Eventually they were confined to a few properties, reservations, which they really didn't have land until the early 20th century. And at one point the federal government thought they didn't have to do anything more for the Washoe tribe because they didn't think that the tribe was going to survive. But it did. And today there's 1,000 or 1,200 Washoes in the area that are located mainly in Carson Valley, on the Rancheria, and then other colonies, one near Honey Lake and one near in Alpine County, near Woodfords. So they were the first ones, but the first big impact on Lake Tahoe was with the logging, which you've all heard about. That started in major industrial logging started in the 1870s. Logging was occurring prior to that for local uses and a little bit of export. But by the 1870s, big-time industrial logging had moved into the Tahoe Basin, and over a period of about 30 years, 95% of the forest was cut. And that's why you see this quote that came out of the Territorial Enterprise in the 1890s, that the Comstock Lode was the tomb of the forests of Tahoe. Not all of the timber that was cut at Tahoe actually went to the Comstock. About a fourth of it went to the construction of the Intercontinental Railroad. But you got to hand it to them. The lumber was very valuable, and so they came up with some ingenious ways to harvest the timber and then to get it to market in Virginia City or up to the rail line near Reno. So what they did is they harvested around the lake, and then either by using temporary railroads or by oxen hauling the large logs down to the lake shore. So everything was brought down to the lake shore, either dragged on wagons, or if it was a big enough operation, they constructed a train, a temporary railroad for it. And then everything was organized into what was called a boom, which is what you see here. It looks like a raft, but these are saw logs that are then towed by steamer across the lake to one of two locations on the east shore. The main mill complex was located in Glenbrook. There were two mills there that operated pretty much around the clock, and then another mill located right here in Incline Village, where the old Ponderosa Ranch is located now, is right there. All this concentrated, though, on the main mill complex, which was in Glenbrook, which was a thriving town. In fact, it was so big, they seriously considered it as the capital for the new state of Nevada. There was so much activity, economic activity, and people here at the time. This is what it looked like in the early 1870s. Sawmills on the shoreline, run by steam, and employee housing around. So you got the logs being brought into Glenbrook, and then from there they were loaded onto a train after they were sawed into timbers. The demand for the lumber out of Glenbrook mainly was in Virginia City for timber shoring in the mines. And so you see on this flat car, they've got the timbers that they used for what was called square set shoring. It wasn't hard rock mining, even though they were in tunnels, so it was softer material, so they had to shore up the mines under Virginia City to keep them from collapsing. And so there was an insatiable need for timber, like you see there. From there, it was put, once it was hauled by railroad up to Spooner Summit, at the top of the Carson Range. It was put into a flume, waterborne flume, at the summit, and then followed the Clear Creek alignment all the way down to an area that's about where the Costco is today in Carson City. And that was the wood yard where men unloaded the lumber, the sawed lumber, onto a train, the Virginia and Truckee, which was built primarily to haul this tremendous amount of lumber into Virginia City and up to the main line in Reno. And then from there, it was taken to Virginia City, where I said it was used in the mines, but also to construct buildings. It was also used, the cordwood was used for fuel and buildings and things like that. But the biggest user of the lumber was the mines themselves. Well, at the beginning of the 20th century, there was a need for there to be irrigation water in western Nevada because the population was growing, and there was a market now for food to feed the population in western Nevada. Even though the mines had collapsed, other forms of industry were sprouting up. And so Lake Tahoe was dammed. Again, it was the second dam that was built. The prior dam was a lower dam, and that was used to store water temporarily and then release it to float logs down the Truckee River. It was another way that logs were transported to market. This dam was to be built by the forerunner of the Sierra Pacific Power Company, but it was taken over by the U.S. Bureau of Reclamation, who then completed the dam in 1913, and it had the effect of raising the level of Lake Tahoe by 6 feet for storage, so they could control the upper 6 feet of Lake Tahoe. Now, naturally, Lake Tahoe only fluctuated about 2 feet. So this dam really raised the water level up quite a bit, and then it held water at higher levels over the winter, and that's why the shoreline is all eroded. When you're out and you see a shoreline is eroding and sediment going into the water, that's the result of the higher levels of Lake Tahoe that were created by this dam. Most of the beaches on the east side of the lake were created by this backshore erosion created by the high water of the dam. There was only on the east side, basically Sand Harbor, the beaches here at Incline, and a few south of Sand Harbor. But the little pocket beaches that you go to now around Thunderbird Lodge and further south, those were all pretty much created by shoreline erosion caused by the dam. Well, while the logging was underway, people realized that Lake Tahoe had a value as a tourist destination. So even as the logging was underway and even winding down, it began to develop a tourism economy. In fact, as early as the 1860s, people were coming up to Lake Tahoe because they believed it had medicinal properties. You could, if you had a cough or some other illness, you could come to Lake Tahoe, and the pure air and the pure water and the high altitude would cure whatever ailed you, they said. So some of these resorts sprung up around the lake. A lot of them were constructed after the logging was over and the forest was recovering and the land was available fairly cheaply. So how did you get to Lake Tahoe, say in the early 20th century after the logging period was over? Well, if you were coming from San Francisco, you would come up on the Central Pacific Main Line to Truckee, and then from Truckee you would take the narrow gauge railway to Tahoe City. It turns out this railway is the same railway that was used at Glenbrook to transport the logs up to Spooner Summit. So the Bliss family, which I had the control of the sawmills and the logging operation with their partners at Glenbrook, Dwayne Bliss, the patriarch of the family, foresaw the transition of the Lake Tahoe economy from a resource extraction to a tourist destination. So he moved everything over to Tahoe City, and in the early 20th century built what was called the Tahoe Tavern, which was a luxury hotel that no longer exists in Tahoe City. And the way they got people to the hotel was on this narrow gauge line, which they had owned and brought everything over from Glenbrook. Well, once you got to Tahoe City, you would board one of the steamers owned by the Bliss family, in this case the steamer Tahoe, and it would take you around the lake. If you were staying in Tahoe City at the Tahoe Tavern, you of course would remain there, but if you were staying elsewhere at one of the other resorts around the lake, the steamer would bring you there, and it would circumnavigate the lake over an 8-hour period. The steamer carried cargo, mail, and passengers. And so this is how people came to Lake Tahoe and got around in the early 20th century until the automobile began to be more prevalent. Well, what did you do while you were up here at Lake Tahoe in the early 20th century? Some of the things you might do is go out on the lake in a rowboat or ballroom dancing. If you were from San Francisco, it was not only important for you to be at Lake Tahoe during the summer, but to be seen at Lake Tahoe, because it was an indication of your wealth and status to be seen at Lake Tahoe and then have it reported back in the newspapers in San Francisco. You might sit out on the veranda of the Tahoe Tavern and play cards or have cocktails with your friends. Or if you were really brave, you'd wade into the cold water of Lake Tahoe. Now these people that you see, they're standing on the lake bottom because there isn't any one of them there that believes that it's possible to float in Lake Tahoe. It wasn't until 1914 that people began to believe that it was possible to actually swim and float in Lake Tahoe. They believed, because of the high altitude of the lake, that the water was less dense than at sea level, and therefore it was impossible for you to float. Of course, we know from physics that's not true, but no one dared challenge that legend, so to speak, until one gentleman who he and a friend rowed out from the Tahoe Tavern. He tied a rope around himself and jumped off the rowboat and swam and proved that you could swim in Lake Tahoe. So from then on, people began to realize it was possible to swim in Lake Tahoe and not sink down. Part of this, too, was the Washos had an elaborate mythology about the lake and about animals that lived in the lake that would come up and get you if you went out in the lake. And so that was created to discourage Washoe tribal members from trying to go too deep into the water and possibly drown from the cold water. After World War II, returning GIs and their families began to come up to Lake Tahoe. The roads were now improved. By 1825, there was a paved road around the lake, and so you could drive here in your automobile. People were actually driving up here as early as 1914. But by the end of World War II, it was possible for the middle class, because of the roaring economy in California, to have the disposable income and the leisure time to come up to Lake Tahoe. So a whole new round of development occurred. And from this point forward, all the development at Lake Tahoe was designed to cater to the automobile rather than the destination tourist. The rail lines were torn up in 1943 to supply steel for the war effort. The steamboats were scuttled. No one was using them anymore. They were considered quaint and inefficient. People got around in automobiles. So now we had motels, hotels, and car camping. And for you to succeed at Lake Tahoe, you needed to be able to be accessible by automobile. Things really took off after the 1960 Olympics, not because of the Olympics necessarily, but just because of the economic pressures and the availability of cheap land at Lake Tahoe. Remember, all the land at Lake Tahoe had been logged, and it was logged as private land, so the timber companies still owned it at the turn of the century. Then they sold it to other private property owners who held the land. So it never, most of the land never passed into government ownership. It was held in large blocks by private owners who then could divide it up, sell it to other people who would speculate and then do subdivisions on it. So I was talking to somebody and they remarked to me that the future, the destiny of Lake Tahoe was determined by the silver strike in Virginia City, and that's true. That probably Lake Tahoe would be a national park, and there wouldn't be very much here if it hadn't been for the silver strike in Virginia City in 1859 that created the demand for lumber that caused the land at Tahoe to go into private ownership long before we had a sense about creating parks and preserving lands and preserving natural features like Lake Tahoe. Well, after the 1960 Olympics, skiing became popular, and suddenly Tahoe began to have a two-season economy. So you've got a raging economy in California, people with lots of money, leisure time. Now people are getting into skiing, and the Tahoe Basin is prime for development because of this beautiful lake that provides all kinds of recreation opportunities. So you began to see things like this, where a large marsh in South Lake Tahoe was stretched out to create prime lakefront, waterfront real estate. This is Tahoe Keys, of course. And this was done before anybody had clear understanding about the impacts of what we were doing. And that's sort of one of the lessons of Tahoe, is that the ability of humans to change the environment at Tahoe far exceeded their ability to foresee the effects that those would have on the lake. Other things like this, and I know you've seen this, you probably drive by it once a day, in which condominiums were just built densely on the shoreline without any regard to aesthetics and that. It caused a sense of alarm among environmentalists, and there was a call for government intervention. People at that time looked to government to solve this problem. And the two states got together and formed a bi-state compact, which under the U.S. Constitution, two or more states can get together and form a compact to manage joint interests or joint resources. Mainly this is done for rivers that flow through one state or another, like the Colorado River. But it can also be done for land use, and this was innovative in that it was done for land use. So the two states got together, negotiated a compact, and then as required by the Constitution, it was submitted to Congress for ratification, which it was ratified and then signed into law by the President of the United States. The first compact was in 1969, and it turned out not to be strong enough. And we had a continued intense development, including high-rise casinos at the South Shore. And in 1980, it was revised, and that's the compact that we operate under now that created the Tahoe Regional Planning Agency, which was given virtual power over almost any kind of human activity. The problem was the TRPA didn't really get the teeth it needed until it was almost too late. All the development had pretty much occurred, and now they were, instead of taking a position of planning future development, they were now in a position of trying to get caught up and undo all the mistakes of the previous 30 or 40 years. So that kind of brings us where we are today. These are some of the questions I get from people that visit, probably some of the questions you'll get, and they're all going to get a copy of my little booklet, right? That has, so all this information that I'm talking about is in my little booklet called The Natural World of Lake Tahoe. That you probably see it around in some of the bookstores here, the few bookstores that are left, and but you get a free copy, so courtesy of UC Davis. So I'll go through some of these questions. How big is Lake Tahoe? Well, it's 191 square miles. So it's, put that into perspective, it's 1/3 of the whole watershed is lake, and 2/3 then is tributary watershed. These are the actual dimensions of the lake. It's a little over 21 miles long and slightly less than 12 miles wide, which you've probably seen these statistics before. You've probably read, though, that Lake Tahoe is 22 miles long, which it is not. Actually, the maximum diagonal or diameter is just under 22 miles. So if you look on a lot of websites or in the newspapers or whatever, they say it's 22 miles long. What they really mean is the maximum diagonal is about 22 miles. There's a lot, and as I go through this, you're going to say, that's not what I read. Well, most of what you read, whether it's on the internet or in newspapers or magazines, is not right. It's not correct, because a lot of misinformation got out there early, and it got repeated, and once it got repeated 3 times, it was considered to be truth. And so we know how that rule goes. A big problem was created by the book, The Saga of Lake Tahoe. There's a lot of misinformation in that book. E.B. Scott did a tremendous job of research, but he got pretty confused on a lot of things about Lake Tahoe, and we're still kind of living with that legacy. The biggest one is that Lake Tahoe shoreline is 72 miles. It is not. It's 75 miles. So where's the 72 miles come from? Well, E.B. Scott, genius that he is, said, well, the road around the lake is 72 miles. Therefore, the lake must be 72 miles because it's completely contained inside the roadway. But he was not considering the fact that the roadway cuts across a lot of these points here where you have more shoreline than roadway. So even though the roadway is only actually 71.8 miles, the shoreline itself is 75.1 miles. If you Google Lake Tahoe shoreline length, you'll get 15,000 hits on the internet that say the shoreline of Lake Tahoe is 72 miles. So just be aware of that. How deep is Lake Tahoe? Now that's one they seem to have gotten right. If we were to cut Lake Tahoe in half and do the measurements of the bottom, you'd find that it's just over 1,000 feet deep on average, based on an average water surface elevation of 6,225 feet above sea level. And if we were to drop the Empire State Building in at the deepest part, which is 1,645 feet, that's measured out in Crystal Bay, which is right in this area. This is the deepest part of the lake right there. It's more shallow here. If we were to look at the lake sideways, you would see it sloping down that way towards the deepest part of the lake. And as I said, if you dropped the Empire State Building into the lake, you'd still have hundreds of feet of water over it. And if you were to take the new World Trade Center tower, it would completely submerge that tower except for the aerial on the top. That'd be the only thing sticking out. It would just be that spire on the top. And the top, the height of that is 1,776 feet, but the spire is a couple hundred, more than a few hundred feet, so it actually would submerge the new Trade Center 1 tower. Consider the next time that you're down in Carson City, think about Lake Tahoe and understand that Carson City is still 85 feet above the deepest part of Lake Tahoe. So as you turn and look back, consider that Lake Tahoe is still 85 feet below where you're standing in Carson City. That always just boggles my mind when I think about it. Well, how does Tahoe compare in terms of depth into other lakes of the world? It's the 11th deepest lake in the world, and I'll show you. There's some deep lakes out here. The deepest lake in the world is Lake Baikal, which is up in Siberia in the Russian Federation. It's over a mile deep. And then it grades on all the way back. Even in North America, there are a couple lakes that are deeper than Lake Tahoe. The Great Slave Lake up in Canada, and of course Crater Lake is deeper than Lake Tahoe. But there are one of the things that makes Lake Tahoe unique is that it's a large lake, and it's so deep. Actually, Crater Lake shouldn't even be in this list because it's not considered a large lake. It's not big enough. We have lots of little lakes, but it's large lakes, of which there's only about 500 in the world, that we compare Lake Tahoe to, and which I'll be showing you some of these comparisons. You probably have read Lake Tahoe is 99.9% pure, right? You read that all the time. And I always laugh because my background is in environmental engineering, which is basically water and wastewater and air pollution engineering. And we know as engineers that raw sewage is 99.93% pure water. Yes. So if Lake Tahoe is 99.9% pure water, like the Chambers of Commerce tell you, this would not be a very nice lake to be in. And actually, it calculates out to this number here, 99.94. What does that mean? That means that if you were to take Lake Tahoe water, there's about 60 parts per million of dissolved mineral matter in it. Very pure, very pure. If you were to go to Rayleigh's here in Incline and buy distilled water, that distilled water would be 10 to 15 parts per million of dissolved matter. Another way to look at this is if that swimming pool that you see there was filled with Lake Tahoe water and we evaporated it all out, we'd have about 3/4 of a teaspoon of dissolved matter, mainly bicarbonates and salts, that would be left as residue. That's one other characteristic that sets Lake Tahoe apart from other lakes. Now you got smaller lakes that are more pure, like up in Desolation Valley. They're all in rock and they get very little tributary runoff. But rarely do you find a big lake like this that has that kind of purity in its waters. Another question I get is, why is Lake Tahoe so blue? And the prevailing myth is it reflects the color of the sky, right? We've all read that, right? Wrong. The way this works, and I have to thank Dr. Goldman straightened me out on this, because one day I asked him, I said, Dr. Goldman, what causes the blue color? And he explained this to me, because I knew it wasn't the reflection of the sky. I knew that wasn't true, but I didn't know what the real reason was. And the way he explained it to me is that as sunlight penetrates into the very clear water of Lake Tahoe, the various colors in the full spectrum of white, bright sunlight get absorbed as it penetrates down into the water. And this phenomenon only happens in clear lakes, meaning not Clear Lake in Northern California, but clear, highly transparent lakes. And what happens is the light can then penetrate very deeply. When it gets down to about 75 feet, most of the colors in the light are absorbed, the red, the orange, the yellow, and all that's left is the blue and the indigo light. So that's why when you're looking far away at Lake Tahoe, it has this blue or cobalt blue color more towards the center. Now, if you're in South Lake Tahoe, it kind of looks green, right? Near shore and under the right light conditions. Well, that, as you can see, green is the last color that gets filtered out. So if you're less than 75 feet deep, like in Emerald Bay or on the south shore of Lake Tahoe, the water is going to look green to you because the green light is still penetrating, and what's happening is this light, as it enters the water, the tiny particles in the water then bounce the light back at your eye. And so what you're seeing is green light in the shallow waters, and then in the deeper water, you see this blue or cobalt blue light if you go out into the center of the lake. On particularly bright sunny days, you can see this pretty clearly, particularly in this late fall when the lake, the sun's still high and the lake is fairly clear for that time of the year. Another question is Lake Tahoe the highest lake in the world? You'll probably read that, it's an alpine lake or whatever. It's actually not the highest lake, large lake in the world. It is the second highest large lake in the world. And again, there are smaller lakes that are higher, but and in the category of large lakes, of which there's only 500, Lake Tahoe is the second highest large lake in the world. The highest is Lake Titicaca, which is in South America, and it's well over 12,000 feet. But it doesn't have a lot of the characteristics that Tahoe has, like clarity in purity of water. But it's as you can see, it's a very large lake. Speaking of large lakes, how much water does Lake Tahoe contain? Well, you've probably heard this analogy. If we were to take Lake Tahoe and dump it out on the state of California, which some people say that's a good idea, particularly now with the severe drought, it would cover the state to a depth of almost 15 inches. That's a lot of water. So now we have this empty lake. How long do you think it would take to refill? How many consecutive average winters would it take to refill Lake Tahoe? And you would have to live for 600 years then to see Lake Tahoe get filled back up again, assuming we had year after year of average winters for 600 years in a row. So that's why people say, and you hear scientists say that what they call a residence time in Lake Tahoe, a drop of water that gets into Lake Tahoe is there on average for 600 years before it finally moves out and on into the Truckee River. So a lot of times the things we do in the watershed that affect the water that runs into the lake, it's in there now, and it takes a long time for that little drop of contaminated water to work its way through the system and get out. But there are other processes that are at work here. In terms of the total volume, this is a comparison that I think is pretty interesting, comparing Lake Tahoe to other large lakes in the world. And you can see the Great Lakes are all larger than Tahoe. The largest lake in the world is Lake Baikal. 20% of the world's unfrozen fresh water is in Lake Baikal. So that's, you're looking at 20%. 20%, think about that. That's a lot of water. And then, actually, in Superior is quite large too. These Great Lakes hold a tremendous amount of water. And so you see where Tahoe falls in the line here. It's even smaller than Lake Erie. But what's unusual, of course, about Tahoe is for a lake this size to be at this elevation. All these other lakes are, for the most part, at much lower elevations than Lake Tahoe. So we got all this water in Lake Tahoe. Where does it go? What happens to it? Well, about a third of it over the long term ends up being stored and then released through the dam into the Truckee River. So what happens to the other 2/3 of the water? It evaporates off. So I always tell people, you know, if we had normal conditions where the Truckee River was flowing and that it's, you know, between 500-600 cubic feet per second, I tell people to go to Tahoe City and stand on Fanny Bridge and look at the water going through the dam, and then imagine a river twice that size going up into the atmosphere off the surface of the lake. So by far, evaporation is the largest consumer of water at Lake Tahoe. Those of us that live here consume a very small, tiny fraction of the total water that Lake Tahoe produces. There's 33% of water. It turns out it's about 500,000 acre-feet a year. 95% of it is produced in the state of California, on the watershed portion of the Truckee River that's in the state of California. But California only uses 5% of the total flow. The 95% is used in Nevada because they were there first and they were using the water before California had a chance to develop its water.
If it evaporates, why wouldn't there be more moisture in our air?
That's a good question. I think it's because we are on the Great Basin, which is a very arid and dry area, and then even though there's a lot of moisture that's evaporating off the lake, there's really nothing to hold it down in the basin most of the time, and so it actually rises and then is blown away by crosswinds, and once it gets out into the Great Basin, it basically disappears. I mean, you're talking there humidities of 10 or 12% on normal. So yeah, that's a good question, because you know I measure the humidity in my house and outside, and you know Tahoe rarely gets humid. We know that. Yet there's all this evaporation of water going on. The question I get too is, does Lake Tahoe freeze? The answer, of course, is no. But why not? And the basic answer is our winter is just not cold enough, and the shape of the lake and the total volume of water compared to its surface area causes Lake Tahoe to retain more heat over winter than it loses over winter. So freezing of a typical lake, and I'll show you here, what happens is when it gets cold, water reaches its maximum density at 39 degrees. It's a very unusual property. It's not maximum density at 32 degrees where it changes to ice or solid. Actually 39 degrees. So as the water cools down from 41, 40 to 39 degrees, it becomes more dense and it sinks to the bottom. So for a lake to freeze, it has to reach 39 degrees top to bottom. Then, and only then, will the water on the top, which is less dense, go from 39 to 32 degrees and form ice. It's kind of hard to get your head around this because it's so counterintuitive to the way other liquids behave. But in the case of Lake Tahoe, what we have is, the winter comes and we get water that cools to 39 degrees, but it sinks and it continues to build up on the bottom of the lake. It actually never gets down to 39 degrees. It gets to 41 degrees. And then by then we get this condition, winter's over. So it's never gotten cold enough to reach 39 degrees maximum density, and so the water begins warming again. So if we had a colder environment, or if Lake Tahoe had less volume, and say it was a more shallow lake with less volume of water, it might freeze. But you take Lake Baikal, for instance, which is over a mile deep, it freezes in the winter. So when you read on the Forest Service website says Lake Tahoe doesn't freeze because it's too deep, that's not true, because we know we have lakes like Crater Lake, Lake Baikal, both of which are deeper than Lake Tahoe, and they freeze over every year. So it's not a depth question. It relates to the volume of water and the surface area and the prevailing climate. Needless to say, with global warming, it's not likely that we're going to see Lake Tahoe freeze over in our lifetimes. Another question I get is why Lake Tahoe is so clear, and there are a number of reasons for this. First of all is, as I mentioned, the ratio of the lake surface to the total watershed. In most watersheds, the lakes are a very small percentage of the total runoff area. But Lake Tahoe is different in that it's 1/3 lake surface and 2/3 watershed. So in effect, you have about 1/3 of the snowfall and rainfall falling directly on the lake surface, so it doesn't have a chance to make contact with the ground and pick up pollutants naturally. So it had this relatively small watershed contributing to it, very similar to Crater Lake. Also, there's just an immense volume of water in Lake Tahoe that whatever small amount of pollution, natural pollution got into the lake, it was immediately diluted out. And then the third reason is that because Lake Tahoe is so deep, once a particle of soil gets into the lake, it continues to sink and eventually goes to the bottom where it's taken completely out of the ecological cycle, the aquatic ecological cycle of the lake, so it doesn't get stirred up very much by wind and that. And we see this in a few other lakes. The thing about this particular process where the pollutants, like the fine particles, eventually settle out, it tells us that if we were able to magically cut off all of the pollution flowing into Lake Tahoe overnight, that within 20 or 30 years, Lake Tahoe would recover most of its clarity. It has the ability to purify itself, and we saw this happen after the logging period, where Lake Tahoe water quality went down in the late 1800s, but then it regained itself, and by the middle of the 20th century, it was well over 100 feet of clarity that was measured by Dr. Goldman. These are the clarity measurements, and as I'm sure you're all aware, clarity has been on a decline. In this case, up is bad, measured by the Secchi disc, and I think you'll probably get into this a little more. The good news that there is in all of this is that you can see that we went through a period where we were losing clarity at about a foot per year, but now it seems to appear to have attenuated possibly, where it's kind of leveling off. This may be the result of all the work we're doing in the watershed to repair the watershed and halt the flow of pollution into the lake. may also be the result of drier than normal conditions, in which causes less pollution to flow into the lake, or a combination of those, which is what I think it is. I think we're seeing a combination of things here. The benefit of the storm drain and erosion control projects that are going on in the basin, plus the drier conditions that we've had over the last few years. This compares the clarity measurements of Lake Tahoe to other lakes. We've got Crater Lake there. This is mainly average clarity. Some of these lakes, like Crater Lake, has had maximum clarity measured of like 130 feet. But on average, Lake Tahoe is still one of the clearest lakes in the world. If it still had its original clarity prior to 1969, it probably would be one of the clearest bodies of water in the world. But right now, it's one of the clearest. It could have been the clearest, though. Maybe we'll get back there someday. So with that, I'll leave you with Mark Twain again. This picture was taken from the spot where he first saw Lake Tahoe. He walked over from Carson City 11 miles and came down Tump Creek. And he kept looking for Lake Tahoe, and he went to the first summit and looked over and said, "No lake there," and crossed over, and then came back up to the second summit, looked over, still couldn't see the lake, and then continued on the road. And he was within a mile of Lake Tahoe before he saw it for the first time, but when he saw it, it really knocked his socks off. And he wrote 10 years later, "We plodded on, and at last the lake burst upon us. A noble sheet of blue water lifted 6,000 feet above the level of the sea and surrounded by snow-capped peaks that rose another 3,000 feet higher still. As it lay there with the shadow of the snow-capped mountains photographed on its still surface, I thought it must be the fairest picture the whole earth affords." So there you've got it, right from Mark Twain himself, his view of Lake Tahoe. So I think we got a few minutes for questions. Be happy to respond. Yes.
The depth of 1,645 feet, that's an average depth you're given because of the snow melt, which we didn't have much this year. Isn't the lake decreasing now? Aren't we evaporating faster than its snow melt is?
Yeah, that depth is measured from the average level of Lake Tahoe, so it's less than 1,645 feet deep now. If the lake was at 6,225 above sea level, then it would be exactly 1,645 feet deep, so you're correct.
It fluctuates during the year.
Yeah, it can be up to 6 feet more, depending on, or actually 4 feet more, I guess. Yeah, right there.
How do we define a large lake? Do you have any know?
Yeah, it's over 500 hectares or something like that. It's an area size to it. Maybe Heather
Like a
can get
volume
that.
or?
No, it's not volume. It's based on surface
Surface
area.
area.
Yeah, it's based on surface area. Determines what is a large lake. So I think it's 500, but I'm not sure.
Hectare is 100 square meters, 100 meters square.
100 meters square. Okay, so it's probably more than that. So maybe you can look that up. Definition of a large lake.
I'll text her. See.
Yeah.
Yeah,
Everyone's sitting
John.
up there.
You happen to know the pH of the lake and how or if the pH is changing?
pH is, I think, a little bit above 7. It's a little above.
So that is actually a really tricky question, and Jeff might even talk about it in his talk. It's pretty neutral, but they're actually realizing that maybe over the last 60 years we've never properly measured the pH because of the way that the instruments record and the way that it works. And so there's actually a study right now to try to see if they can figure out if Jeff talks about it, I'm not too privy to the research, but there is someone who's working on right now another way of looking at recording pH.
What's dissolved in the lake is mostly bicarbonates, carbon dioxide based or carbon based, and oxygen. carbon and oxygen combined, like CO3 or whatever. And that tends to make it more base, meaning a little bit higher than 7. But there's not enough in there to make it get really strong in that regard. So I think generally it's considered neutral or just above neutral in terms of pH. Yes?
What, if anything, is done to the water that we're drinking in the way of processing?
Depends on where you are. Where are you?
Crystal Bay.
Crystal Bay. Do you get water from Euclid?
From whom?
Yeah, Incline Village?
Yes.
Yes. Okay, your water is drawn directly from the lake, and then they hit it with ozone and as a disinfectant, and then they probably put a little bit of chlorine in it, enough that you can't taste it, and then it's distributed from there. But the last time I looked at the Incline Village water system, it was strictly treated with ozone.
It's also UV.
Huh?
UV.
Oh, UV, yeah?
Yeah.
Oh, have they converted over, or?
Yeah.
Oh, they have. So I stand corrected. It's ultraviolet radiation, which they have ultraviolet emitting tubes, and they expose the water to that, and that ultraviolet intense radiation will kill anything that's alive in the water that would be harmful to you. But originally, the original system I know was ozone, so they probably, because of the cost of producing ozone, changed over to ultraviolet radiation. Other areas, if you're down towards South Lake Tahoe, you might be getting filtered water because the water isn't pure enough down there. There's a lot of urbanization around the shoreline, plus it's shallow, and so they would have to go out too far. They'd have to go out, 5-6 miles or more to get into clear water that they would not be required to filter for public health requirements. So you're probably getting filtered water, but it does vary around the lake. I know over in Tahoe City, in that area, it's all well water. And so all that's done with that is they add a little bit of chlorine to it to keep the bugs from growing in the pipes and that. And if you drink the water, you really don't taste it. It's a good question. Ask Crystal Bay Water Company to give you a report, and they'll tell you what they do. But if it's in fact UV, then that's a good indication. That means they're not doing very much. Believe me, bottled water at Raley's is given far more treatment than Lake Tahoe water. Far more treatment.
If you set water out, does the chlorine evaporate out?
Mm-hmm.
So
Yeah,
basically,
it volatilizes and it'll come out a solution. So you can do that. So if you've got like fish tank, you let the water sit for a few days, or you add sodium thiosulfate to it to knock out the chlorine so it doesn't kill your fish.
I understand that Tahoe has a filtration exemption, so the water that's pulled out of the water does not have to be filtered
Right.
for most of the lake.
Right.
And so that saves a lot of money in terms of treatment, water treatment.
Yes, yeah, that's true. And we'll see how long the filtration exemption lasts, because Lake Tahoe still isn't getting any better. I was very skeptical of the filtration exemption when it was issued, because I could see Lake Tahoe water continuing to get worse and treatment plants being required. So depending on where you are around the lake, like Heather says, that you may have to have a treatment plant to purify the water.
The flip side of that is, you mentioned the sewage is all pumped out of the basin.
Right.
Where is it processed?
Well, again, it depends on where you are. If you're in Incline Village, the plant is right here in Incline Village, and then it's exported out into the Carson Valley, and then I think it now goes across all the way over to the Pine Nuts, where it's reclaimed and used for irrigation water. South Lake Tahoe in California, the plant is in South Lake Tahoe, and it's exported out into Alpine County. And there it's stored and used for irrigation on ranches in Alpine County. On the Nevada side in South Lake Tahoe, where the casinos are, the plant is right there near Whitell High School, and it's exported out again into the Carson Valley. And I think their pond trying to think. I think you can, if you're coming down Kingsbury Grade, you can actually see a couple square ponds out on the valley floor. Those are the storage ponds for Douglas County Sewer Improvement District. And then finally, the California side from Emerald Bay all the way around the state line in Kings Beach. That all flows by gravity to Truckee. And the plant, there's an advanced wastewater treatment plant in Truckee, in the Mars Valley near the airport. It provides a very high level of treatment. And then from there it's put into the ground, and over 3 to 6 months it migrates into the Truckee River. And then it's reused by cities of Reno and Sparks, and also by irrigation diverters use it. But it's such a small fraction of the total flow, you would be hard pressed to find it in the water. So it gets back, I live in that service area, so we're in a drought now, so the standing joke is flush twice, Reno needs the water. Yeah, John.
I think there's an interesting misconception a lot of people have when they come up, and that is that everyone who lives in the basin gets their water from the lake.
Right.
And I believe in actuality, less than half of the people living in the area get water from the lake. The South Tahoe Public Utilities District is the largest provider, and they have no water rights in Lake Tahoe. So that's something I try to tell people, that it isn't what it appears in terms of water.
Yeah, you think it's, the lake's right there, and it's like, well, that's where you take your water, right? But it turns out it's more expensive to do it that way than to take it from springs or vertical wells. Like South Tahoe PUD has a whole well field throughout that area, and there's plenty of groundwater. And when the groundwater comes up, unless it's been polluted by a gas station or a dry cleaner, the water is fine. And I think groundwater actually tastes better than lake water. To me, lake water tastes flat because it's so pure. It tastes like distilled water, really. And people that have had both, I think, do prefer the groundwater or spring water because it has a little more dissolved matter and it tastes a little better. Fond memories of his time at Lake Tahoe, and I hope that you share those same kind of memories. Now, this is a quick overview of the cultural and environmental history of Tahoe. Basically, it's how the environment and people have interacted together to make Lake Tahoe what it is today. But we begin with the first inhabitants at Lake Tahoe, which is the Washoe tribe, which have inhabited the area for about 1,300 years. There's been human presence in Tahoe probably longer than that, but organized as the Washoe tribe. This was their summer grounds. They would come up and camp around the outlets, the streams, and fish for the native Lahontan cutthroat, which are no longer in Lake Tahoe. And they camped in family groups. They also held Lake Tahoe to be the spiritual center of the tribe. So not only did Lake Tahoe nourish their bodies, but it also fed their spirits too. And there are certain areas around the lake Tahoe. I always like to start though by talking about Mark Twain. He came up here in 1861, and he was actually going to stake a timber claim, but he was so moved by the lake that 10 years later he wrote in his book Roughing It 2 chapters about Lake Tahoe, and he called it The Fairest Picture, The Whole Earth Affords. And he actually camped up here in the North Shore near Tahoe Vista. Fortunately, he started a wildfire and realized campfire get out of control. But he wrote very eloquently about it, and it was the lake that he compared all other lakes to. He traveled around the world. Lake Tahoe was his gold standard that he always compared other lakes to, and no other lake ever measured up to Lake Tahoe. Strangely, though, once he left the area, he never came back. So he always held the tomb of the forests of Tahoe. Not all of the timber that was cut at Tahoe actually went to the Comstock. About a fourth of it went to the construction of the Intercontinental Railroad. But you got to hand it to them. The lumber was very valuable, and so they came up with some ingenious ways to harvest the timber and then to get it to market in Virginia City or up to the rail line near Reno. So what they did is they harvested around the lake, and then either by using temporary railroads or by oxen hauling the large logs down to the lake shore. So everything was brought down to the lake shore, either dragged on wagons, or if it was a big enough operation, they constructed a train, a temporary railroad for it. And then everything was organized into what was called a boom, which is what you see here. It looks like a raft, but these are saw logs that are then towed. The government thought they didn't have to do anything more for the Washoe tribe because they didn't think that the tribe was going to survive. But it did. And today there's 1,000 or 1,200 Washoes in the area that are located mainly in the Carson Valley, on the Rancheria, and then other colonies, one near Honey Lake and one near in Alpine County, near Woodford's. So they were the first ones, but the first big impact on Lake Tahoe was with the logging, which you've all heard about. That started in major industrial logging started in the 1870s. Logging was occurring prior to that for local uses and a little bit of export, but by the 1870s, big-time industrial logging had moved into the Tahoe Basin, and over a period of about 30 years, 95% of the forest was cut. And that's why you see this quote that came out of the Territorial Enterprise in the 1890s, that the Comstock lode was that hold very strong spiritual value, like for instance Cave Rock. Only certain members of the tribe were allowed to go near Cave Rock. They would make offerings to Cave Rock and would receive the wisdom from the rock that the shamans would then return to the tribe. After summer, they would all then relocate out of the Tahoe Basin, obviously because of the winter snow, down to the lower valleys in Carson Valley and as far north as Honey Lake, where they harvested pine nuts, and that was also a major staple in their diet. They're still in the area, but their tribe was pretty much decimated with once Tahoe became overrun with Euro-Americans in the late 1800s. Eventually they were confined to a few properties, reservations, which they really didn't have land until the early 20th century. And at one point the federal